We can also do what's called a midpoint Riemann sum. So let me take a moment. We're going to do midpoint Riemann sum. I want to make sure that in your notes it says that you should only have two triangles, or excuse me, I keep saying triangles, two rectangles. So we're going to mark out this 4 right here if it says 4 in your notes and put 2. And again, we always start by setting up an integral, because what we're doing is we're approximating a definite integral. We're approximating area underneath the curve. So we've got 0 to 12 f of t dt is approximately, so that's what I did back here, right? I've got an approximation sign here, approximation sign here. These are not exact. This is not geometry formulas that I'm using. And we're going to do m sub 2. So this is going to be midpoint. So let me show you how I use the table. I'll also do a little drawing here. So now I'm only doing 2 rectangles. So if I'm going from 0 to 12, now my width is going to be 6. So these are going to be my 2 rectangles. If I'm going to go from 0 to 6, let's take a moment here to come over to my data. If I know I'm going to go from 0 to 6, I want to pick the height that is in the middle of that data. So the height at 3 would be what I want to pick for the height of the rectangle. Then I'm going to go from 6 to 12. Okay, so you always start here, right? You don't go 9 to 12, right? You go from 0 to 6 and from 6 to 12. That's what creates those 2 rectangles. And then the height of that one is 54. So I can see based on my data exactly what the height is. I don't have to go to the graph. But if I'm going to use my graph, this is the middle. And you'll notice that I'm going to be a little under the actual graph and a little over. So this is going to be my first rectangle. And then there's the middle there. So this is my second rectangle. I'm trying to use the different colors where you can see it. So now let me go ahead and use my pencil, kind of give us, so this is the first one. Again, a little bit over the curve and a little bit under the curve. I think y'all can see my curve right here. I'm trying to make it a little bit darker coming through. It's barely concave up, right? So a little bit over, a little bit under, which hopefully would make my answer a little bit more accurate than the 498 or the 603. So we're going to come back here. We're going to set this up as now my universal width is going to be a 6. And the height of the first was 37. The height of the second is 54. Take that, put it in the calculator. We get 546 feet because that is a distance measure. Now, because it's a little bit over and a little bit under, there's not a definitive over or under estimate. So we're going to make a note of that. So cannot define as over or under estimate. Over or under estimate. So we know it's a little bit closer to the actual distance traveled, but I can't say it's absolutely under or over. Now 546 is kind of in the middle of these two, but not exactly in the middle. You're going to be very tempted to try to average these. Okay, note, do not average right and left to find midpoint. You have to use the actual middle. So the average will not get you that 546. And you're going to want to, so be careful.